And I'm live. That is pretty cool. And today is 7th of September 2025, Sunday. And here is what we have been doing. CP31. If we go to our sheet in CP31, we have done all the questions at 800 level, 900, 1000, 1100 to 1200, 1300, and 1400. And now we have to begin with 1500 questions. 1500 rating questions. Okay, after completing 1400 rated questions, I did a few streams about theory things, and I guess, well, that certainly wasn't enough, but I guess that did help us in some way to get ready for the new things. And now let's do a few questions. First, we will set our tmux and then attach, and we will create a new folder named 1500, and we will go into our folder 1500 and start new vim and update some plugins. Lua snippet has an update. Okay, this is the question. This is a division 4 question F. That is cool, and the rating is 1500. Okay, let's just see how it goes. I don't think this should be much more difficult. Like, I don't expect the level between the difficulty of this and 1400 to be pretty high, but let's see. Okay, this can take up to 5 seconds. That is crazy. Let's start the stopwatch. Okay, we will do this with a stopwatch, but the main goal is just to, while we are doing the question, just to be there, do the question. Okay, there are n people on the number line. The ith person is at point AI and wants to go to point BI. For each person, they want to move to the right, and the starting and ending points of all people are distinct. That is, of all two numbers AI, they are all distinct. Okay, all the people will start moving simultaneously at a speed of 1 unit per second until they reach their final point BI. When two people meet at the same point, they will greet each other once. How many greetings will there be? Note that a person can still greet other person even if they have reached their final point. They will move at a speed of 1 second, 1 unit per second. So they are all moving simultaneously, and they will stop once they reach their destination. Okay, that is kind of easy to know, right? We don't need any simulation. How many greetings will there be? We can okay, for a given starting point, we have T, then we have N, and then we have E and BI. EI, N lines follow. Okay, and in the lines we have this. Okay, okay. We can store these as a pair, and then we will sort them. And then we will sort them. Yes. Let's take some example. Let's take this one. This is big enough. We have this thing, and we will take them and we will sort them. This is 0, let's say, and we have one starting points are with green. We have one starting point here, and we have one starting point at 3, at 4, and at 1. And then we have a starting point at 7 and one at -2. And red are the ending points. The first one is at 5, which is about here, between 4 and 7. And then the second one after 5 is 6, which is also here before 7. And then we have 9, which is around here, and also 8 before 9, and then 10, and then 100. And how are the connections? From -2, we have a connection. The ending point is here. For 1, the ending point is at 8, which is after 7. And for 2, the ending point is at 6, which is this. For 3, the ending point is at 9, 8, 9, this one. And for this, which is 4, the ending point is just at 5. And then for this, the ending point is here. Okay, we are going to count when a person goes from their location till the ending point, how many people are they going to greet? And this guy is going to greet all of them, all the people, which are 5, which is 5. And then this person starts from here and goes till here. And in between, how many pairs, how many complete pairs do we have? This person will start from here and will stop here. This person will start from here and is going to go past the end point, so we will not meet him. And this person starts here, and I messed up in making the diagram. This person is also inside. Okay, so that is cool. And this is our end point. So this guy is going to greet this one and this one. 2, 5 plus 2. And then when we move on to this guy, he starts here and ends here, and in that interval we only have one pair, so +1. And for this guy, we start from here and we end here, and in that interval, how many complete pairs do we have? We have just one complete pair, so +1. And then for this one, we do not have any complete pairs, so +0 for this one. And then for this guy, we do not have any complete pairs, so +0. And the final answer should be 9. Let's check, and it is 9. Now, all we have to do, we can arrange them. First of all, we can sort them in their increasing order. First, on the basis of the first their starting point, and then on the basis of their ending point. Yes, and how are we supposed to find the answer actually? Can the time complexity be n square? Two n numbers, n is 10 power 5. You cannot do n square. We just have to find, given a pair, how many other pairs are there in between that. And by in between, we mean their starting and their ending point is between our current pair. We need to find their count, and individually going through everything. How's that? Can we go individually? I think we can. I think we can, because we will stop whenever we see that the current pair is outside. No, we can do binary search actually. Since everything is sorted, we can do binary search. We can do binary search. Binary search. Let's see. -2 and 100. That is going to be the first thing. So we will sort according to the first number in ascending order, and then if the first number is same, then we are going to first number is never going to be the same. That makes a lot of sense. First number is never going to be the same. So everything will be sorted according to the first number only. Yep. Everything is going to be sorted according to the first number. We can store these two in no in two different vectors. Binary search. Okay, we know the theory, at least. We know how to solve, we know what we have to do. We just have to figure out how we can do that, right? Maybe binary search or something. Given a pair, we have to figure out how many other pairs are in between this current pair. We know the starting point and the end point of the current pair. All we have to figure out is how many other pairs are there in between. And our method has to be efficient. And of course, our thing is going to be sorted with the according to the first number, but the first number is always unique, so we will never have matches. Yes, we will never have matches. And let's say this is our range that we are considering. This is a very bad looking range. Let's say this is our range that we are considering, and since the pairs are sorted according to their starting point, then we might have first of all a pair like this, and then maybe pairs that are in between. So when we see that our current pair is going out of bounds, we cannot just stop. We have to keep moving till we see that the first point of a pair is not inside our range. Wait, can we sort them according to their size? But yeah, that is not pretty cool. If we do sort them according to their, if we actually do sort them according to their size, it doesn't feel good. It doesn't feel good. Can we use memoization in some way? No. Let's first of all write the basic solution that we have thought of. Just implement this in the most basic way. Maybe this will take any square because this is going to take 5 seconds. 5 seconds is the limit that we can afford. So maybe that is how it is supposed to be done. Cn, and then we will have a vector of pairs of integers. We will call it a, and the size is going to be n pair of integers. And then for int I equals 0, I less than ni plus plus, and Cn a I dot first, or we can write a much better loop, which is somewhat like for auto ij in a Cni j. Now we have everything we want, and now we can simply sort a dot begin and a dot end. After sorting, let's have long response equals 0. And for int I equals 0, I less than ni plus plus. Let's do int j equals I plus 1. And while a j dot first, while a j is lower than n, and a j dot first is smaller than a I dot second. While we are within the range, we will do if a j dot second is also in the range, then response plus plus j plus plus. That is actually enough. Run shit. Okay, I will not. We will not look at what went wrong. That is not supposed to happen. Shit, that is actually not supposed to happen. Yep, we did sort it, and we are retards. We are no, not like we. I am a retard. Okay, that does work, but that is not very efficient. That just feels like it is taking n square time complexity. Let's see. Let's see. Well, at least we can. Okay, let's rewrite this whole thing and then submit, just to be sure. Int n, c in n, and vector of pair of integers a size n, and then for auto, we will not make the same mistake. A j I j in a will take c in I and j, and then sort a dot begin comma a dot end. After sorting, we will have long response equals 0, and for int I equals 0, I less than n, I plus plus, we will have int j equals I plus 1, and while j is lower than n, and a j dot first is lower than a I dot second, we are within the range, and if a j dot second, the second part of a j is also within the range, then we will have response plus plus, and in any case we will have increase j, and let's see if that is correct. Of course that is correct, but it is taking a lot of no, but it is taking a lot of time, which is bad. We do not want that. TLE, 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 TLE. Time limit exceeded. Time limit exceeded. That is what is going to happen. Time limit exceeded. Error. See, it is still running. Yeah, time limit exceeded. So our solution is not very efficient. We know what we have to do, but it is not very efficient. So let's think about it for maybe 10 or 15 more minutes, and then we can look at the solution. It would be fine. Wait, something, can we use some kind of prefix? Uh, prefix. Let's go with this example. This one, this is a nice example. We know that our solution is correct. Like it is correct, but it is not very efficient. We have to make it efficient. This thing is 0 and green is our the starting points. And let's also sort these into the ascending order. 1 8 and then 2 6 and 3 9 and then 4 5 and then 7 10. That is the ascending order. And here we have our first point at -2, then second is at 1, then 2 3 4 and then the last one at 7. And our ending points are scattered all around. Yep. Our ending points are scattered all around. First one is like at the top at 100, then the second one is at 8, which is one more than 7, then at 6, which is one less than 7, then at 9, one more than 8, then at 5, one less than 6, and then at 10, which is one more than 9. And this one, okay, let's also label them. This is bad. 1 2 3 4 and 7, the last one. And also the ending points are like 100, 8, 9, 10, 5 and 6. And the connections are like this. This 2 is connected to this 100. This 1 is connected to the 8. Let's do that. 1 connected to the 8. Then this 2 is connected to the 6. Like that. 2 is connected to the 6. And then this 3 is connected to the 9. And then this 4 is connected to the 5. Connected to the 5. And then this 7 is connected to the 10. Those are the connections. Now, is there some clever way? Ooh, no. Ye- I think there might be a clever way. Somewhat like prefix. Okay, shit. It feels like there is some clever way here, which clever trick that we can use. If we start iterating from the start, we see at this point we do not have anything in the middle. Yep. Shit. Okay. 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 Let's take a counter C, which is going to keep count of how many pairs um inside how many pairs we currently are. Hello. Are you reaching solving 1500 problem just in 2 months? More like 3 months from not exactly zero. I did a little bit of advent of code, so I'm not new to programming. Reaching 1500 requires knowledge of good advanced topics like BFS, DFS, DP trees, and a really good Ad hoc thinking. Yeah, if you study BFS and DFS and do a bunch of questions, then they do not seem that advanced, right? It feels like a bit easier, like get used to them and get familiar with them by just solving questions on DFS and BFS. DP is also fine. Trees are also good, and ad hoc thinking you just develop. So there is nothing in these few topics that you have written which are they are hard, but they're not like you cannot do them. So yeah, I'm doing them. So let's say you have a counter. You keep a counter of how many. No. How would you see inside which pair you are? Because when I enter a pair, I have to keep track of the end point of this particular pair. I can just minus. Whenever I see a end point, I can just minus 1 from my counter. That works. That works. Okay. Okay, so initially we start from here, okay, and we see that we are at a starting point, so we add 1 to our counter. So currently our counter is 1. Then we get to this point and we see that we are at a point, at the starting point of a point, so we add 1 to our counter. Hmm, 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 hmm. Yes, we can do this. We can do this if we change the format of storing things. Yes, we can do this. And then for 2, we see we are again at a starting point, so plus 1. The counter is currently 3, and then we are at 3. We see again that we are at the starting point of a counter, so plus 1, and then we see 4. Okay, cool. And when we see 4, we add again 1 to our starting point, to our counter. So we are inside 1, 2, 3, 4, 5 pairs currently. And then we see end point of 1. So among all of these pairs that we are inside, one of them exited. And since we are still inside C minus 1 pairs, we are going to add to our response, to our answer, 4, because these 4 pairs have this removed pair inside of them. And then we see this. So when we see this, we are going to add, nah, yeah, that is bad. No. No, it is wrong. It is wrong. It is wrong. It is not going to work like this. This is wrong. This is wrong. No. Because we cannot just assume that when we are here, this pair is the one that we are removing. But we are still considering ourselves inside this 3, 9 pair. But this pair that we are removing is not inside this 3 pair, right? Because 3 started after 3 after 2, so 2 is not inside 3. Hmm. So that is wrong, but that was fine. That was fine. The idea was kind of fine. So still we are unable to come up with a solution. We have written a solution which is very bad because it is giving us time limit exceeded error, but it is correct. At least it is correct. We have to optimize this. Okay, we can see that at points we are repeating tasks. Yes, maybe. No, maybe not. No. maybe if we sort our array on the basis of the length, but still that would not help. That still would not help, because we would still, given our approach, we would still have to go from the starting point till the end point of a current pair, through all the pairs which are there, which have their starting point between the starting and the end point of the current pair that we are at. So that is also not going to help us. What can help us? God? No. 1 and 8. The basic approach is the only one that is coming to mind, to just see, to just go through every pair and check if this pair is inside our current pair or not. And this is the question that we are trying to solve here. This one. Yep, this one. Greetings. Greetings. 1915. Shit, 1915, by the way, is the year when general relativity came out. And World War One was 1 year old. Hmm. Okay, what do we want and what do we have? Let's say we have a pair, right? We have a range like this, and all we need to figure out is how many ranges are completely inside this range. That is, how many ranges have their starting point and their ending point inside this range. That is the only thing we need to do, but we need to do this for all the ranges, right? So we will count ranges like these. We will count these ranges, this one, and this one, but we will not count this one because this one only has its starting point inside this original range, but not the ending point. And we will also not count something like this, which had the starting point before, but the ending, only the ending point is inside the range. Is there a, is there something that we can pre-calculate? Wait, we can easily, given our sorted array, find out all of these ranges which have their starting point within our specified range. This would be easy to find out. This thing would be easy to find out how many ranges have their starting point inside our given range. And then we can also see, can we see how many ranges have their ending point inside our given range? But that would also include this range. We do not want something like this. And when we do that, we can find their intersection. But to find their intersection, we literally still have to go through all the pairs. Yep. Or so, but this is like already too much work, I think, because we are first creating a set or maybe an array, a vector of all the ranges who have their starting point inside our given range, and then we are creating a set of all the ranges, or which will be represented by their index, not the pairs, of all the ranges who have their ending point, and then we have to take the intersection, and this thing we are going to do for all the ranges. It is already too much overhead to find one single thing. Why are you solving like that high? Oh, see the title. Shit. Oh, shit. The title is not completely visible. My bad. Look at this. We are going to reach 2000. I'm going to reach the rate 2000 rating. By the end of this year, I have to reach it. That is the target. So 1500 is not a big deal. It is a big deal right now. Right now it is hard. I'm unable to figure out the solution. But yeah, we have to get there to just prove a point. We know the solution. We just have to figure out optimal way to find it. In 5 minutes, we will read the editorial because we do not have to feel bad about looking at the editorial. Our main goal is to grow, is to learn new things, and it would be very bad, I would even say very stupid, if we were, for example, if I were learning something very complex like general relativity, and I said that I am not going to read books on this thing. Instead, I'm going to observe everything I see around myself. I am going to observe the moon, and then I will create my own relativity, and then I will check with the books, did I got the thing right? No, that is bad. That is not how we do it. So in this also, there has to be a way, a generally accepted optimal way, which can be used in a question like this, where we are going to find ranges which lie completely within a given range. And once we have seen that, we know it. We didn't have to discover it for ourselves. It would have been cool if we could discover it on our own, but we were unable to, so we can read about it in the editorial. That is fine. Hello, why you wanna reach it? Will it help too much for our job? Like, will you give a quick motivation? Like, will you give a quick motivation to reach 2000? Okay, why reach 2000? Bec- Well, first of all, there is my own personal philosophy that if I'm not doing my best, then why am I even alive? And what is the point of even life? Right? But that you do not have to care about that. Reaching 2000. Why do you think you cannot reach 2000? 2000. It is hard to reach 2000, but if you really try, I think you can reach 2000. And for me, this is, I do not care about getting a job because I know I will get a job. The reason that I'm reaching 2000 is specifically is because I want to show myself and to you guys also that you can reach 2000. And if you can do that, you can also do some amazing things. This is one of the hardest things you can do, you can decide to do, reaching 2000, because ratings. Look at this. Not this one. There is a picture of Excel sheet. This one. Look at this. If we see, even at 1900 level, there are only 5% people, top 5% people are there. No, percentile, top 6.7% people. And if we go at over 2000, at 2100, we have only 1.6% people. So it is very hard. It is very hard to get there. And if we can do this, then we do not have to be afraid of a lot of things. And I want to solve 1502 with you. Yep. What's to do? I do not know your current rating, but it would be cool. You can start from 800 and then slowly go up the ladder and keep reading and seeing new things as you go along. That would be cool. This is the sheet, CP31. You can start from there. And yep, we can now look at the editorial. But before looking at the editorial, let me state specifically what we want. We are not just looking at the editorial to look at the whole solution. Our goal is this. Our goal is find an efficient way to find the count of efficient way to find the count of ranges which begin and end within a given range. That is what we are trying to look for when we read the editorial. This is the only thing. And if we know this, we can solve the whole question. So looking at the editorial does not mean that we don't even understand the question. We just want an answer to this thing. Find an efficient way to find the count of ranges which begin and end within a given range. And by range, we mean left value and right value. Right, left. Let's see, not announcement, the editorial. Pupil. Yep, I'm also pupil. Right. Yep, I'm also pupil. Very bad. Right, very bad. Greetings. Yep. Let's consider persons 1 and persons 2. When do they meet? We know the answer to this thing. They meet, like if we have person 1 here who starts from this point and ends at this point, and we have person 2 who starts within the range of person 1, and this is person 2, and also ends within the range of person 2. Only then, while person 1 is moving, person 2 is also moving, but person 2 will stop at this point and person 1 is going to move past this point, and when person 1 and 2 both are here, person 1 will meet person 2. So we only read this and we knew the answer to this thing. We can treat a person traveling from point A to B as segment AB. Notice they meet when A1 is smaller than this, and yep, so A2 and A2 and B2 are both within A1 and B1. That is correct. Or we can say, wait, is that an indication as to our answer? Notice they meet when, okay, so if we find for A1 all the points which make this thing true, A2 smaller and A2 is smaller than A1. How did we just switch the sign? Okay, when yeah, the opposite way, the opposite way. When A1 is between A1 and B1 are between A2 and B2. Yep. Yep. In other words, when one segment contains another, we can count the number of pairs when one fully contains another, which is a quite classic problem we can solve by iterating over the segments in increasing order of B positions. In increasing, okay, let's think about this thoroughly. In increasing order of B position. In increasing order of B position. We can do that. Have you solved 14? Yep. Here 1400. Done. 1331. 3131. And here we have this thing. Okay, they said that this is a classic problem, quite a classic problem. Okay, let's see. We have our line segment like this. 0 is here. Let's first of all, let's sort this whole thing according to the endpoints. So first we will have 5, 4, 5, and then we have 2, 6, and then after 2, 6, we have 3, 1, 2, and then we have 3, 9, and then we have 7, 10, and then we have -2 and 100. That is what we have, and let's put them down on our list. First we have 5, which ends around here, let's say. Then 6 ends around here, 8 and 9 and also 10, and then 100. Let's label them: 5, 6, 8, 9, 10 and 100. And then for the starting points, this 5 is connected with something at 4, then 6 is connected with something at 2, then 8 is connected with something at 1, and then 9 is connected with something at 3. This is 1, this is 1, and then 10 is connected with something at 7, which is here, and then this 100 is connected with -2. Let's mark the connections: -2 and 1 with 8, 8, then 2 with 6, and then 3 with 9, and then 4 with 5 right here, and then 7 with 10. Okay, and they said this is a very classic problem. Okay, so we should know this. We begin with this thing. In ascending order. This is quite a classic problem and can be solved by iterating over the segments in increasing order of B position. And I'm intentionally not reading the whole thing, right? I'm intentionally reading till here only because we should be smart enough to figure this out. Current rating is just 1200. Yep, about 1200 right here, 1200. I lost quite a bit of rating being stupid here. So what do we do with this? I guess we know how many endpoints we have seen till now. So for this, answer is going to be 0. Like we haven't seen any endpoint till now. And then when we are here, we have seen one endpoint, just one endpoint. And we need to also see how many beginning points are here, or the endpoints that we have seen. Do they lie? Do they lie within this range? Do they? That would again result in n square time complexity, because when at this point we do not want to go through everything. Iterate and compare with 5's short point sort. Okay, I do not get this part. Iterate and compare with 5's start point. Yes, but that okay, that is what we did here. That is the exact same thing. Instead of going with the end point here, we iterated with the starting point. But that in that case, time complexity is going to be too high, and we did this thing and we got time limit exceeded error. Now we want some efficient way, more efficient way, right? This one is bad. So I think whenever we see a point, okay, shit. No, no shit. Y- Yes. Whenever we see a point, we will have a set. We will have a set. Let's have a set. Shit. Yes, yes. Let's have a set. And let's say for we just added this one, 4, 5, and our set is going to be in ascending order with the first starting point. And then when we are inside this thing, we will see in this set will only contain the points whose end point is to the left of the current point. And in this set, we can use binary search. And in binary search, we can give our custom function and we will look for no, we don't, we can use lower bound, I think. Yes, we can use upper bound. We can use upper bound and we will pass in into upper bound R2 and we will get the first index that is greater than 2 and we will count how many things there are in that set. Okay, shit, this works. This works. This works. This works. We got this. We got this. We got this. We don't have to read the rest of the thing. We got this. Scene and here we will have a vector first of all of pairs. Yep, A size n and for auto reference I comma j from A we'll have C in I into j and then we will sort A dot begin A dot end and a custom function pair of integer or we can use auto. I really want to use pair of integers I and pair of integers j and we will return I dot of second is smaller than j dot okay, now this thing is sorted according to the endpoints and we will also create a set of pairs, let's call it s, and we will now iterate for int for auto reference s and e starting we are using s for the set so we cannot use s here, s and e inside a and long this equals 0. And we are intentionally not using unordered set here because unordered set is going to take is can be slow, can be really slow here. Yes, what has been the time complexity till now? For the sorting part, time complexity was n log n, and then this thing we are going to go through every set and internally for every pair not every pair. For every range, we are going to use etmax and log n. So log n time. So in total, the time complexity is going to be n log n. Worst case. Now, to iterator s dot upper bound for I comma 0. Yes, we can use that because only the starting point matters and not the other point. The other point would only be looked at if the starting points match, but they are not going to match. Upper bound, we got the upper bound, and this plus equals s dot end minus it. Shit, we cannot find the size. Yes, we cannot find the size because this is associative. This is associative. This is associative. Uh, Given iterator to an element in a set, how to find how many are greater than that. Maybe there might actually be a function. Iterator. This is too big, too small. Distance. This is the distance from iterator to the end, but this might be actually pretty small. And also we cannot use unordered set here because we need the property of the set in which the things are sorted. Now we can do this without ChatGPT. Get number of elements greater than a current number 4 years ago. Stack Overflow, given a question, I do not think there is any STL in which suits your need. You must use STL tree.h. Yep, find the lower bound, size, insert, distance. This is definitely log n. Yep, this is bad. We do not want log n thing. Yep, we do not want log n thing. Log n, this is log n. Can we use something other than set? We cannot. We cannot. Nope, we cannot use something other than set because where are we going to store the. Actually, the second value does not matter. The second value actually does not matter. So our set doesn't have to be a pair. Only the first value matters. Shit. Only the starting points matter. Upper bound for I. Yo. Yep. TLE. Lower one instead starting point at 2 also count. But I have not added the point. So here I have not added this current point and all the points are distinct. So lower bound and upper bound will work the same. But I want this thing S to be sorted. And if I were to just add element to a vector at the end of a vector and then sort it again and again, that is not very efficient. All we need is this. A vector would be very nice. A vector would be actually pretty nice. Wait, this a vector would be very nice, but it is not sorted. It is not going to be sorted. We only need something that is sorted. A set is sorted, but it is associative. We cannot just subtract iterators in a set because that does not work, because set does not provide random access. We cannot even do it plus 1. This is going to give us error, but we can do it plus plus. This is fine. We cannot do this because this does not give us random access. But if we had a vector, for example, auto it, let's say vector a dot begin here. If we did, wait, first let's remove this. If we did it plus 2, this will not give us error because a vector iterator gives us random access. We can go anywhere we want. We can go back if we want. But a set iterator does not give us that. Let's do upper bound with I. All we have to do is just find how many numbers are bigger than this. Shit. All we have to do is just find out how many numbers are bigger than this iterator in a non-linear way would be very nice. A non-linear way would be very nice because we are already going through n time, and internally upper bound takes log n time. So we are already at n log n time. Store in vector and sort, but think of that like this. I will have to do the sorting every single time I am in a loop. Like for example, if I were to use a vector int v, let's say, and auto iterator, if I use this auto iterator equals v dot upper upper bound v dot begin and v dot end, and we are looking for I. Let's suppose that v is sorted, then we would do v dot pushback what, pushback I, and then v dot sort, like sort v dot begin and v dot end. That is not very good. That is not, that is going to take n log n time. Yep, that is going to take n log n time. And think of it also that if we have v like this and see everything is sorted here. In this, let's say everything is sorted and the size is n. And then we added a new element to our vector, and then we called the sorted function. And let's say this vector, this new element has the smallest value in the whole vector, then this will go to the first place, and when that happens, we will have to move this originally first element to the second place, the second element to the third place, third to the this place, this to here, this here, and this one will go here, which is just n time. We cannot do that. It is going to give us TLE. So that is not good. Can we just do send? What is send IT? No, we are this set S only has the things which we have gone through. It only has the ranges which we have gone through. That is all the ranges till this current range, before this current range. So when you add something, you need to sort it because it might not be at its proper place. Yeah, let's do ChatGPT for our specific query. I am to a list, and as I go, I am adding numbers to some data, and then when add a new element in my null list, I want to see many of how many numbers that I have passed to are greater than the number. So all I want to know is which data structure I can use here. Set is good since when I add new elements, it is in sorted order, and I can also use upper bound, upper bound, but set is associative and doesn't give random access, and thus I can't just do set dot n minus it, which is iterator. And if I were to use a vector, then adding then using the upper bound and then subtracting from dot n, I can find the size easily. But the problem is when I add when I add a new number, I want the vector to be sorted, and this is going to take an log n time. Bad. Classic. This is also a classic problem. You basically need three things in one data structure. Keep numbers sorted as you insert them. Yes. Query efficiency. How many numbers are greater than the current number, and insert efficiency as you iterate through the list. Yes. Set makes the thing sorted. Yep. It also gives us upper bound, but no random access. So in worst case, the time it takes to find the count of numbers which are greater than our current number is going to take n time. So that is bad. In vector, maintaining sorted order is very bad. Insert and find rank. Policy-based data structure. Shit, I think this is not the thing that would be in the solution. Policy-based data structure, ordered set. Can we use s.n? Nope, we cannot do this. Be okay, shit, that is what you meant there. No, we cannot use this because look at this. What S gives us when I do auto IT equals S dot upper bound to some number, let's say 5. Then what this IT is, this IT is essentially a pointer to a node in a red black tree. And if you do S dot end minus IT, this is not going to work. See, there is error. This is not going to work because in a set, when you are iterating through an iterator like IT here, you do not get random access. That means you can only do IT plus plus and IT minus minus. From a given node, you can only move one step forward and one step back. You cannot do IT plus one. See, this is giving us error. You cannot do this because how can you jump through nodes? And wait, Excalitor is right there. In trees, we did trees yesterday. Yep. Okay, yesterday's work is lost. In trees, when we have a bunch of trees, red black trees are like this. When you get IT, iterator auto, it points to some node, and when you do IT plus plus, it goes to the next node wherever it is. But what you cannot do is IT plus some constant number, C, let's say 5. How would how would you know where the fifth node after this thing is? You cannot know. The only way to know this is when you go to the next one, then whatever the next one is. In this case, there is no next bigger node because we are already at the rightmost node. But if your IT points here, when you do IT plus plus, your iterator goes to this node. And when you do iterator plus plus, your iterator goes to this node. And when you again do iterator plus plus, you go there. But you cannot do IT plus 5 or 4 in this case and jump directly here. You have to go through the order in which the nodes are presented in the tree. Yep, this is a new concept. It is only solved by policy-based set. Hmm. And even though they said that this is a classical problem, hmm. Classic order statistics problem. I guess my way or our way of approaching this is not pretty good because I don't think C++ or competitive programming is going to use some niche structure like this using namespace GNU PBDS, but they do use the GNU C compiler. But we won't get this thing in Clang. I use Clang, so you can look at the editorial. Yep. Yeah, but do we get the problem correctly? I think we do get the problem correctly. We do understand what is being asked. The only problem is this part. How do we see how many numbers that we have passed through till this point are greater than our current number? For that, we need order wherever we are storing the numbers which we are passing through. We need them to be sorted. We need we need them to be random access. But you cannot do like this. Let's go greetings. Okay, we read till this point, position B. And for each of them, adding the number of segments that we have already passed to that have an A value larger than the one of the current segment. Okay, yes, okay, but how do you do that? How do you do that? Okay, you do that. Shit, okay, this is what they are using. This is exactly what they are using there. This thing, but I do not have this in Clang. I don't think I will be able to use this. I cannot use this. I do not have GCC. Shit. And okay, how to add a GCC libraries to Clang. That is what we need. ext. Okay, okay. So there are some libraries which are extra in GCC which are not present with Clang. And my work, because look at this LSP info, the LSP GPT without PDBS. Okay, GPT without PBDS. Wait, what? GPT? This thing is just not there. This is a GNU specific thing. And the problem is this. The LSP that I'm using is ClangD. It is by Clang. And this library is by GCC. And now what we can do is add all of these extra GCC libraries into a folder, into this folder, which Clang? Clang is in this folder. So if we go to this folder, home to seller LLVM, we can either add this to this folder, or maybe we can create an extra folder in which we can add all of these extra libraries and make our compiler, Clang compiler, and our LSP point to that folder by default. We can do that. It would be pretty nice. Hello. Yep, today is a constant contest and it is going to be pretty cool. Now, can we take higher complexity? Yeah, yep. Back to back 3-day contest. Yep, it is going to be cool. This is why I quit New Vim. This is why you should stick to New Vim, study yourself. Uh, now, well, I see what we have to do. We have to add these extra libraries into some folder and point our compiler and our LSP to that folder. And also, shit, since I from time to time also use a debugger, LLDB, I also have to point the debugger to that folder. No, I don't have to. I don't have to. I don't have to do that. I don't have to do that because when I compile, my debugger already has all the linked files. So that is cool. Okay, now the question is, all of these extra libraries, are they all in this ext directory? Uh, Here we have some extra libraries that only GCC and are not there with clan, and undo all of these libraries only in the ext directory. GCC specific extensions are not. Since I have GCC installed, I think I have. not this one. Let's go to homebrew. I have OPT. I have new latest GCC installed in homebrew. Seller GCC at 12. Let's wait. Install GCC. I think GCC's current version is 15, which is the latest one. Yep, contests are there. Contests are there. It was a long time. GCC 15 is already installed and is up to date. So we need to go into that folder, cd/opt/homebrew seller GCC, yes, GCC and 15 version, and lib ls. What do we have here? We have GCC ls 15 ls. These are all the things, but these are dynamic link libraries. dy lib ls include cdc++. cd include, let's use newvim for this, c++ 15, and we have all of these things extra. This is the thing that we need. Okay, but not just the header files, we also need link files. So we have found the folder that we were looking for, which is this folder, and we can just copy paste this folder to some place which we can point our compiler to. We also have the bits folder here. That is cool. Bits std c plus plus is not here due to some reason. I think I deleted it. Okay. We have to copy paste this extra folder, but there are the include files. Then where is the exact library? Library GCC, let's say current, and okay, ext is not here. Do we have ext here? Nope. Where do the actual files exist? So we have the header files, but we do not know the link files. Bitmap allocator. Okay, let's actually read some of these things. We have error here because our LSP does not know about these things. Bits require hosted.h utility. Okay. And these header files in ext directory, do they depend on some other external things that are specific to GCC? And if they do, are they all within this directory? And are they all within this directory? And also do these only include declarations or also or do they also include the definitions? Okay, std what lives inside, they are GNU extensions. Okay, ext is not extra, it is extensions. It means extensions. Okay, atomicity, low level atomics, shit, atomics. They are part of libstd++ implementation, GCC's implementation. No external libraries are needed beyond, it is self-contained. So they depend on GCP specific internals. Yes, but only in the sense that they are implemented using templates and this and some GNU macros. Like this, as long as you are using, so I can just point my compiler and my LSP to this parent library instead of trying to copy paste things to this thing to 15, which would have all of these things. Okay, let's do that. Let's do that. How can we do that actually? And we have our LSP configuration file in library, preferences, clang b, LSP, config.yaml. Here is the file, and we can change this to include opt seller or opt home brew seller, and I don't know the path, which n opt home brew seller gcc 15 and include C++ 15. That is the path. Include C++ 15. That is the path. We can copy this and we can paste this here. And hopefully this works. Hopefully this works. Hopefully this works. So if we go back to Tmux, attach TCP, do we get some error? Okay. LSP restart. Do we get some error? Yes, we do get some error. Bits was not found. Library preferences, YAML clang D. That is bad. N opt homebrew seller. Okay, Apple Arch. What is there? It only has XTD. That makes more sense. No, that does not make more sense. This thing does not include STD C++. Makes sense. Makes sense. So if I were to include this, I would have bits And here also std c++ will also be there. This thing, arch 64 apple darwin 24. Append this, and hopefully this works hopefully. TCP, and if we start, what do we have? We only have one thing, f greetings.cpp. Okay, this thing does not give us any error. Yes. That is because of the version. Shit. Now Clang D knows that there is this file which it has to include, but inside this file, this thing is not being included. If glibcxx hosted, then do this, but it is somehow not glibcxx hosted. Okay, so I guess I will do this off stream on my own. I won't bore you guys with this. Not bore, this is actually pretty fun, but this is going to take a bit of time. Now we have to solve questions. We know how this is going to be solved, right? So we can just move on to the next question for today. Smilo. Smilo. Okay. We can start the stopwatch also. Okay. 1.5 hours given, but not a single question done. But we do know, we exactly know what we have to do, right? Declaratively, but we do not know the imperative solution, how to do it. And that is fine. Smilo and Monsters. But before we begin, I would like to go to the washroom and I will be right back. Back to back, 3 days contest. Yep, it is going to be fun. Yo. Let's move on to the next question, even though we haven't been able to do a single question, but that is fine. That is fine. I will configure my setup so that I can use those specific exclusive GCC libraries, and that would be pretty cool. That would be nice. Now let's do this question. A boy called Smilo is playing a new game, Factorial. In the game, there are n hordes of monsters, and ith horde contains AI monsters. The goal of the game is to destroy all the monsters. To do this, wait, have I done this one? No. To destroy all the monsters, you have two types of attacks and a combo counter X. Combo counter. Initially set to 0. Two types of attacks and a combo. The first type, you choose a number from 1, I from 1 to n. N is the number of hordes that we have, such that there is at least one monster left in the horde with the number I. Then you kill one monster from the horde number I, and the combo counter in x increases by 1. Okay. The second type, we choose a number I, one of the horde, says that there is one monster left. Then you choose an ultimate attack and kill X monsters from the horde. X monsters use the combo. After this, X is reset to 0. Okay, your task is to destroy all of the monsters, meaning there should be no more monsters left in any of the hordes. Smilo wants to win as quickly as possible, so to he wants to the minimum number of attacks required. He wants to know. No is not written there. He wants to know the minimum number of attacks required to win the given game. That is cool. That is cool. Okay, so we have this many herds. In the first herd, there is just one monster. In the second one, there is this, and in the third one, there is this many monsters. I guess we go from the smallest. Herd. Shit, but we use the second type of attack, our number of attacks increases by 1. We do kill X monsters, but X is reset to 0. So here, when we kill this monster, let's say we choose this horde and we kill this monster, X is 1. Now, either we increase our X with this, or we kill this. Half, 50%, 50, 50. I think the answer, without going through the simulation, I think the answer for this thing, for the sum is 6. The sum is 6. We can go half, 50. 6, 3, 3, and so we do have to kill at least 3 monsters. At least 3 monsters. And we can use the second combo 2 times. So 5. 4 is the answer here. 4 is the answer here because why? Because 2. How is 4 the answer here? Once we, let's say, use our first attack and kill this monster, then we use the first attack and let's say we kill this monster, and then we use the first attack and we kill this monster. Now we have 3 and we can use that on this monster. That makes sense. But when the answer is odd, 1, 2, 3, 4, here also the answer should be 4, and it is 4. And here the total sum, and yes, the total sum. In any case, we would not want to do the first type of attack more than half the times, like this. So here the total sum is 6, 11, and 17. And 17 is odd. 17 is odd. We divide 17 by 2. and we add 1, we get 9. So we have to do first type of attack at least 9 times. And when we do that, we can increase our x at max 9 to 9. And when we do that, let's find the sum. When we do that, we can sort this thing also in the descending order. We will have 5, we will have 9 attacks. We can, in 9 attacks, completely kill this 5th monster. Then we will have 4 attacks left, which we can use here. So the answer is 11. 9 plus 2, 11. And here 7 is the maximum thing. And therefore we have to do this thing at least 4 times. We have to do, yeah, we have to attack at least 4 times. 4 times. We will have x equal to 4. We will start iterating from the maximum element till the sum. Wait, we don't even have to. We can find the prefix. I think we can find the prefix and then find out the sum, the value of x. When does that value? And find the first prefix value which is greater than our x, and including that point, because we will have to use our x on that point, including that point, we need greater than our x. Yep, including that point till the end, how many elements there are, how many, however there are, that would be our answer added to x. Okay, cool. This makes sense. We can do this. Hey, could you please tell how many hours and how many problems you solve every day, roughly? Wait. Yep. Back to day 3. Yep. It varies, but I try to do at least one problem. And yeah, at least one problem. I come on the stream and I do solve problems. But some days my focus is more on reading theory. Like right now it is about dynamic programming. And yeah, so some days I'm majorly reading and some days I'm majorly solving questions. And when I'm also like going into theory and reading problems, then also I'm solving questions, because when I'm reading, they give examples and we have to solve the examples that they are giving. How many problems have you solved roughly apart from code forces? I don't know. I have solved some lead code problems, some other problems from, let me show you, from this book, CLRS, Introduction to Algorithms, taken from my college. Yeah, there are problems in the examples. Roughly, I don't know. I wouldn't have estimate. mm, t- 20. I've also solved some CSES problems. But like, the count does not matter. The count does not matter. A few CSES problems here, there, and let's begin. Let's continue with this thing. Do I know what I am doing here? Yes, I do. Yes, I do. Yes, I do. Sit, not here, not here. Into Tmux, attach PCP. Let's go and boilerplate. Yeah. Okay, include users, my name, and there is a folder include. Think that is the folder. Should there is no include folder? Should where is the include folder here with n dot slash zshrc? It has to be here. Yep. Dot locally slash include. Okay. Copy. This is on my question solving time. This is taking time. Now the LSP should work. If we restart the LSP, that is. Yeah. It's no errors. We don't need this. We simply need a prefix, but we need prefix for the sorted array. But and okay, vector of long prefix size n plus 1 and I equals 0, I less than n, I plus plus, and pref I plus 1 equals prefix of I plus ai, and then long x equals pref n. The last, no. The totals, we want the upper limit when divided by 2 plus 1. Mm-hmm, mm-hmm, mm-hmm. We have this. Now we need our iterator to the first element with the upper bound equals to this. Upper bound from ref dot begin, comma, ref dot end. Yes, yes. Put in x, put in x, and answer is going to be x plus ref dot end minus it. Int answer equals ref dot end. Okay, now when we have that number, do we want to include it? Yes, we want to include it. Yes, yes. Okay, this feels like it is correct. It is correct. It is correct. That does work. Hello, major learn and done. Code force. Yep. Yeah, code forces, and for practice we of course have CACS. CACS is pretty cool because CACS is based on the competitive programmer's handbook. Yeah, so written by the same person. and his name is Anti-Laksonen. This guy, Anti-Laksonen. This one, this guy created, yeah, from the University of Helsinki, Finland. He created CACS. Now, since our solution is working on the local thing, we need to go through the solution and check if it is correct. But what we can do is rewrite the whole thing, and not in while we are in the actual contest. In a actual contest, we should not do something like this. But here we are only practicing, so we can do this. Vector int a for int I equals 0, I less than n, I plus plus, cn ai, and sort a dot begin, a dot end. After sorting, we need a prefix of shit, ll, long, ref size n plus 1. And yep, for int I equals 0, I less than n, I plus plus, and ref I plus 1, not 12 plus 1 equals prefix of I plus ai. When we have that, we will know that long x equals ref of n plus 1 divided by 2, and then auto iterator upper bound ref dot begin and comma ref dot end. We are looking for x, and yes, we are looking for the upper bound. And now the answer response is going to be x plus ref dot end minus it. It does work at a school. Let's see. Submit. I don't know. Is it going to work? I think this should be correct. This should work. This should work. This should work. This wrong answer on test 2 would be okay. Wrong answer on test 2. Wrong answer on test 2. So it does not work. It clearly does not work. What could be wrong? What? Prefix. Shit. Do not tell me it is because of this. If it was because of this, that would be a little bit stupid. Because we are adding x. Shit, I didn't notice. I thought, yeah, shit. Okay, x. We are adding x, and x is a sum of very big numbers. That actually could have been the error. No, I think there is some other logical error because they would not give us very big numbers in the second example. Uh, okay, that was the thing. That was the shit, shit. Okay, so that was the thing. That was the thing. But now we have it. We got this right. It took us, let's say, 19 minutes to do this. 19 minutes and refresh. So this one was cool. Let's now do some research on this question. Okay, let's try to first of all predict or guess what the tags are going to be. So my guess is that first of all we will use sorting. Sorting was completely used. Sorting prefix, sorting prefix, binary search. Yeah. So we used sorting, we used prefix, and we used binary search. So let's see how much we got right, because they sometimes feels like they give just random tags. So binary search, sorting, constructor algorithm, greedy. Yes, yes, yes. The whole meta structure was greedy. 2 pointers. I thought they might say 2 pointers, but okay. Now the editorial. That was cool. That was actually cool. That was actually cool. 19 minutes. 18 and a half, 19. Now the editorial, hide the tags. It is taking pretty long. And is this updated? Is the rank updated? And by the end of this year, this thing would say number one. Yo, we have to go there. We have to be number one. Go to the editorial. Shit, this was by this guy. That is very home gateway thing to say. C. Smilo and Monsters. Yep. Note that if the second operation were free, we would need this sum. Yep, that is true. Operations to get rid of all the monsters. Indeed, when we kill one monster, we can kill a second monster for free with the second operation. But the second operation is not free. So we need to use the second operation as little as possible. As little as possible. That would be when we are killing the monsters, killing the maximum number of monsters in a single row. To do this, we need to apply ultimates. Second attacks on the current largest horde by number of monsters. Yep. When the combo counter reaches the size of the largest horde, we will apply the first attack on the smallest hordes. First attack on the smallest hordes. This is so because the combo counter also uses time complexity is n log n log n, because we did sort the list that we got, allows us to defeat the upper limit of some monsters. See, we also took the upper limit here. Prefix n, the sum of the whole thing, plus 1 divided by 2. Sum divided by 2. But since we can't apply this operation on several hordes at once, we need to keep the number of hordes on which we apply these attacks of the second type as small as possible. Yes, to decrease the number of count for the second operation, for the second attack. Then we can use the greedy algorithm described above. Formally, we need to keep a sorted array and store 2 pointers. Shit, they are actually simulating the whole thing. You don't have to actually simulate the whole thing. To the smallest node, j to the largest node. Until I is equal to j. If after destroying all hordes, I cannot kill horde j with ultimates, we destroy horde I, increase pointer I by 1, and until I is equal to a is equal to j. If after destroying all horde I, we cannot kill horde j with ultimates, we destroy horde I, increase pointer I by 1, and increase combo counter x ai. By xai. Otherwise, hit the horde I so many times that the combo counter x becomes aj. Otherwise, hit the I so many times, then then applying a second attack on horde j reduces horde j's counter by 1. Reduce ai and nullify the counter attack when I becomes equal to j. Shit, I do not want to like simulate this thing. Hello. Yeah, this one is not pretty good because they are simulating the whole thing, and simulating is takes too much logic, too much thing that you don't even need. Okay, so we did that one, and we can move on to the next question. And yep, we can move on to the next question. Black sequence, it says. Hmm, block sequence. I saw a question about blocks in a recent contest. Yep, there was a question which used dynamic programming on something related to blocks. Now let's start this one. Given a sequence of integers a of length n. A sequence is called beautiful if it has the form of series of blocks. This, okay, each starting with its length. The length, if it has the form of a series of blocks, each is starting with the length. Okay, that is first comes the length of the block and then its element. For example, the sequence this and 1 8 4 this are beautiful. Different blocks are colored differently. While this is not beautiful, this is not beautiful, this is also not beautiful. In one operation, can you remove, in one operation, can you remove one element from the sequence? What is the minimum number of operations required to make the given sequence beautiful? At every position, I either have the choice to remove this thing or not to remove this thing. And we can start iterating from the end, because given a thing, we only care about what things were on the right, and we can start iterating from the end and come to the front. Say for something like this, our answer should be 0. Okay, this seems to be using dynamic programming, and we can start iterating from here, from the last bit, and consider this is our problem. Or let's say we are at any random index and I have a choice to remove this or not remove this. And if I do remove this one, then is the remaining thing a thing? I know. I know that in this part, how many numbers there are and how many operations it would take to make this thing a block, a beautiful sequence. And here it would take 0 insertions or deletions to make this a beautiful sequence, because we have 2 and then we have 2 numbers. So if I do delete this thing, then I did one operation here plus the number of operations here, which made this thing beautiful, 0. Yes, so answer here would be 1. And if I do not delete this thing, if I do not delete this thing, I have to see, can I just leave this here as it is? If I do leave this here, if I do leave this here, then I need to see how many things. If I would need to have 5 things here, and after 5, whatever the answer is for whichever this imaginary thing here is, answer for that would have to be 0, because that has no, 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 no. Answer for that would be this plus that. We got this. This uses dynamic programming, and let me directly implement this. Mm, Start new vim, CPP, boilerplate, int n, c in n, take in n, and what do we need now? Now we have n and we have a vector of integers a size n, and for auto, for int, reference x in a, c in x. And then what are the limits? Limits are also fine, very, very fine. Okay, we can create our vector in teacher. Let's call it table. We will not call it what everyone calls it. Now let's have our base condition. Base condition, which is going to be tab n minus 1 equals 1. Because no matter what the last number is, we would have to remove it to make our sequence till that point beautiful. Now, for int I equals n minus 2, we will begin from there, and I less greater than equal to 0 and I minus minus. And what we need to calculate is tab I, and it is going to be the minimum. Now, first we have to see, can I keep this current number? If AI, 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 the value AI, if it is smaller or equal to n minus I minus 1, int, let's say keep equals, if we keep this, if we remove this current number, then the answer would be tab of I plus 1, and int, if we keep this, answer is going to be int max. Now, if we can keep this here, we have to see, is this correct? If AI, the count, is lower than the remaining numbers, the numbers that are to the right of I, which is n minus I. Yeah, yeah, this is cool. This is cool because yes, this works. This works. Or more clearly, n minus 1 minus I. That makes more sense. We are subtracting 1 from the last index, which is n minus 1. Now, if this is the thing, then A is going to be equal to 1 because we did one operation here, and not just this, plus 1 because we removed the current number. If we keep this, then answer is going to be tab I plus AI plus 1, AI plus 1. Wait, what? Yes, from I, we have to go AI elements to the right and then plus 1 because we do not want to include AI. And now tab I equals the minimum of remove and keep. And at the end, cout tab 0. Okay, that does work. We do not have to be very happy about it. Let's rewrite the whole thing. And c in n vector int a size n for int reference x in a, c in x, take in x, and now we will create a vector vector integer, we will call it tab size n, and tab n minus 1 is going to be 1, and then for in I equals n minus 2, I greater than equal to 0, I minus minus, and if we keep it, if we keep n remove, if we remove, then I plus tab I plus 1, but if we keep it, then in max, and for if ai smaller than equal to the number of elements that are remaining, which is I minus 1, n minus 1 minus I, and if that is the case, then keep equals tab I plus ai plus 1, and tab I equals the minimum of the two, remove or keep. See out tab 0 when we are at the first element. That does work. Let's see. That is not possible. Did we submit the wrong code? That is literally not possible because it is working here. It is working amazingly here. That is literally not possible. Uh, and is always going to be at least 1. Client plus plus p block dot slash out. Yes, so we are getting 0. Yes, 0 4 1 1 2 1 0, 0 4 1 1 2 1 0. What is wrong? What is wrong? What is wrong? Because we are getting the correct answer. We are getting the correct answer. Hello, DSA with Java? With Java or C++? I like C++, and there are a lot of people who do not like Java. Linus Torvalds, who created Linux, he actively abuses Java. And I think Richard Stallman, who created GCC, he out, bounds, out of bounds. The Richard Stallman, who created GCC, he also abuses Java. Now to learn DSA, which language should I? C++ would be better. C++ would be better. Go with C++ because there are a lot of things with C++ that would help you in stuff. You will learn a lot of low-level concepts with C++. So go with C++. That would be nice. Yes, we do not have to include the current element. But we were not including. We were not including the current element. Wow, with this give error. And minus 1 minus I minus the current element, the index of the current element, and this will give us how many elements are to the right. Okay. That makes sense. That does make sense. Tab n equals 0. We need a edge case when we need all the elements there. Yes. Yes. My bad. Yep, it should work now. I didn't write the base case correctly. Okay, shit, if we are going with this, we can even skip this part and we can directly skip there. Start from the last element. And now submit. This should work. Third semester from a tier 3 college and logic will नहीं वो है कैसे logic. If you want to build your logic, then okay, this is accepted. We can stop the timer, 16 minutes. Then I would recommend something like this, add-on of code. Okay, I didn't have any logic. My logic is still not very good, as good as I would like it to be. But this is the place where I started solving questions. And yeah, I think without this, if I hadn't done this thing, add-on of code, I wouldn't be liking solving problems as much as I like them now. So this thing was one of the major things, and I would recommend everyone to do this. This is one of the best things you can do if you want to get better at problem solving. So this thing, add-on of code, you can solve this, and this is highly recommended. Highly recommended. Just go to this thing and solve this, and yeah, solve a few problems. They give you a question in this, and you can look up on YouTube and other places what the format of this thing is. They give you a question, right? You have a whole question, and question is divided into two parts. Part one, and you go through everything. You read how you are supposed to take input and how you are supposed to give output. And then there is this thing, get your puzzle input. Click on this thing, and on the next page you will have the input which you have to take in. So you copy this whole thing and you have to paste this whole thing into a file, and then in your programming language read this whole thing, read your input, and whatever your program outputs, enter that input here, and if it is correct, you will get access to the second puzzle for the day. So here I entered that my answer came out to be 4602, and then I got access to part 2 and I solved part 2, and yep, this was the answer. And I can show you the answer because inputs differ for users. For different users, they have different inputs. So that is also cool. It took 16 minutes to do this one. I hope that would help. This is like literally one of the best things that you can do, add-on of code. Okay, that got right, but we were able to solve this question, but we got wrong answer on test 2 because of integer overflow. And in this, we got wrong answer on first try because of out of bounds. Implementation is not very good. We have to improve our implementation. I have to improve my implementation. And what do we have? Let's predict the tags. It is, of course, going to use dynamic programming. Dynamic programming is going to be there. And yeah, what else? This was basic dynamic programming question. Not basic, but it didn't use any s- fancy things. This only used some dynamic programming. Yeah, So you don't see anything else. It is just dynamic programming. Let's read the editorial for E. Shit, we are slowly getting to the last question. That is cool. Let's use dynamic programming approach. It was Mr. Mike who wrote this question. That is cool. Let dpi be the number of operations required to make a segment from 1 to I. And they are also going from end to the start. Segments from I to N. Beautiful. There are two possible ways to achieve this. Remove the element at position I and make the segment from I to N minus 1, I plus N minus 1, I plus 1 to N. Beautiful. Then dp of I is going to be whatever the dp of the next element is plus 1. And second, make the segment from I to ai plus 1. Beautiful. And then dp of ai plus 1 would be whatever the dp dynamic programming was whatever the answer was from the element which is not part of our current block, and see whichever is the minimum element, take that into your solution. Yeah, so that is cool. We got that. And I would quickly have to go to the washroom and I will be right back. uh, Very quickly. Shit. Yep. And we can begin. We can go to the next question now. Data structures fan. Yeah, data structures fan. Shit. So is this going to be data structure intensive? Yep. Drink water just after coming from the washroom and start. You are given an array of integers from a1 to an as well as a binary string consisting of only zeros and ones, consisting of n characters. Augustine is a big fan of data structures. Therefore, he asked you to implement a data structure that can answer Q queries. There are two types of queries. One LR, LR, one query number one, query number two, query of type 1 and type 2. And there are this many numbers, integers as well as a binary string. Okay, we have two things. Replace each character SI inclusive left and right with its opposite. Okay, that is replace them. Okay, and then G, calculate the value of bitwise OR of the numbers for indices I such that of the numbers AI for all indices I such that SI equals G. G is shit. How do we even do that? Shit. Okay. Okay. That is messed up. That is That is messed up. Shit, what are the constraints? No, it is full blown. It is full blown. N goes to 10 power 5. Zor has memory. We can use that fact to our advantage. Flip. Flipping in a certain range. Okay, I got the answer. I think we need to have a few things to solve this one. We need to have a few things to solve this one. We will take a counter for XOR for zeros, and we will keep track of all the XORs of 1, and we will have a prefix, two prefix, one prefix for zeros and one prefix for ones, where ith at the ith index, we will have XOR. Okay, we don't even need this. We don't even need this. At the ith index, we will have XOR of all the zeros till this point, and same XOR of all the elements which correspond to the to character 0 in the SI string. And same for the this other XOR vector for 1. And whenever there is a query, we take XOR till the left point and XOR till the right point. Find the XOR of this range by taking XOR of all the elements till right with the XOR of all the elements till this, because XOR has memory. XOR has memory because we have A XOR B XOR A. This is A. This thing equals B. If you take XOR of one number twice, that is A XOR A is 0. And then if you take zeros XOR with B, you just get B. So that is cool, and we will need to keep track of a bunch of things. No, only two things. A vector for XOR of all the ones and N, C in N. And what do we have? How is the input format? First we have the numbers, and then we have, wait, okay, queries. Then there are the queries. Then there are the queries. Okay. Okay. Vector integer A size N, and for in X in A, C in X. And now this thing is vector integer. How big is A? Vector integer XOR 0, Z0, size N plus 1, and XOR 1 size N plus 1. And now for char C in S, if C equals 1, no, we need index for int I equals 0, I less than n, I plus plus, if si equals 1, then x1 I plus 1, x1 I plus 1, yes, x1 I plus 1 equals x1 I XOR with AI. There you go. Else x0 a plus 1 equals x1 x0 I, the last thing, XOR with AI, and then end q, c in q, taking q, and while q minus minus in L and R, C in left and right, and okay, no. We will not always have this. We will not always have this. We will not always have this. We'll have a char t, t as in type, taking t, and if t equals what 1 in t, c in t, taken t. Now we know what the type of the operation is, either 1 or 2, and if t equals 1, then we will have two numbers L and R, C in L, R, and we need to update nah, we messed up. We messed up a little bit. I've done this question. So that is cool. That is cool. I will do this. I will also do this. That is a bit wrong because you would have to, the numbers are changing, so we'll have to update the whole prefix. No, we don't have to. Int XOR x0 all equals x0 n, and int x1 all equals x1 n. We can just update. The problem is that our prefix is not changing. We can reflect the changes on this. But do we want our prefix to change? Do we want our prefix to do we want our prefix to change? For some example, for example, 2. This thing is this. if we do go with this in our prefix for zeros, we will have 0 for the first two numbers, and then we would have 2, and after 2 we would have 1. This will work because we are always flipping. This will work. This will work. This will work because we are always flipping, and this will work. X0 all, take its XOR with X0 index L minus 1 XOR with, let's say, change is going to be equal to X X0 L minus 1 XOR X0 R X0 R is inclusive. Cool. Okay. Take XOR of this whole thing with Y0 L minus 1 Y0 L minus 1 XOR Y0. What is Y? What is Y0? X1. We have X1 or X2. X1 0 L minus 1 XOR X1 R. That is the change which will be reflected in both the things, because whatever zeros or ones were there, XOR is amazing. XOR is cool. XOR is cool. All take its XOR with change, and Y X1 all XOR, take the XOR with change, else int G C G C and G, and if G if G, then G is 1, then C out, and the next line C out X0 all. Mhm. Okay, okay, it doesn't work. Okay, so where do we mess up? We mess up at the very last line. Space, we need a little space. Space or a new line depending on G. G equals 0, not not G. If G is 0, then 1. And we can use the same trick here. Space, new line, not G. And we can remove this. The format is correct, but it does not depend on G, it depends on Q. My bad. 7 is correct. 7 is correct, but we messed up some with something else. When there are more numbers, we are messing up more. Wait, how can we even mess up with the first operation? Don't. Yeah. How can we mess up with the first operation itself? 2 should have been 3. Answer for this thing is 3. X0 all in new line and C out X1 all. And the naming scheme is not very good, but it works. What is the name of the question? E plus plus data out dot slash out, only one test case, and in that test case which we have this stuff. Now there are 7 query. Uh, how did you got the answer? We said we have 1 test cases. Uh, uh, how did we got the answer already? We took in n, right? And then we went forward and took the whole array, and then we took the whole string, and then we took q. Okay. We didn't get the answer. 2 and 0 are the they are saying that 0, not they. I'm saying that sort of the whole XOR of all the numbers which have an index of like which correspond to the value 0 is 0. How? We take XOR of 1 and 3, we get 2. When we take XOR of 4 and 2, we get 6. When we take XOR of 6 and 5, 5 is 4 plus 1, we do not get a 0. We get 6 and 5. What is the XOR of 6 and 5? 6 is 1 1 0 0. 6 is 1 1 0. 6 is 1 1 0. Yes, 6 is 1 1 0. 5 is 1 0 1. We take XOR, we get 3. So 3 is what we should have gotten, and not this. 1. What is the XOR of the elements with 1? XOR Ah, X one I plus one equals X I. That makes a lot of sense. Because when we are not updating that, we should be updating the other thing, and now the answer is correct. And now we are going to delete the whole code and we will write it from scratch. Int n, cin n. Wow, bro, which resource or channel should I follow for bit manipulation and bit masking? Batman. I would say, well, first of all, there is always Eric though. We always have Eric though. And second of all, we can stop the stopwatch right now. We have Eric though. Yes, he also has stuff on. Yes, he has stuff on bit mask. He has a video on bit sets, and he has a video on bitwise operations. So that is cool. And also, you can read about bitwise operations in the CP handbook. There, CP handbook, and there is a whole chapter on bit manipulation. Yep, right here, bit manipulation. You can go through this thing. And also there is CP algorithms, where if you go to navigation, there you will see bit manipulation in miscellaneous bit manipulation, and there are things about bit manipulation. So that is what you can do. That is cool. And now going back to this question, we take in n and then we create a vector integer via, and for integer reference x in a, c in take into x, take into account, take into x, and then string s, take in the string s. And now we will have our prefixes things, x vector integer x, x1 of size n plus 1, and x0 xor 0 size n plus 1. And then we will start iterating for int I equals 0, I less than n, I plus plus, if si equals 1. If we have 1 in there, then we will add the current number to x1. x1 plus 1 equals x1 I xor with ai, and x0 will not change. It will remain as it was for the last number. Else, if that is not the case, then we increase the value, or we take XOR for x0 with the last value, with the current value of ai, and for 1 we x1 we keep it same as it was. And in here, integer 1, let's call it ones. Ones is equal to x1 n, and integer zeros is x0 n. And now in q, c in q, and while q minus minus int t as in type, taking the type of the current question. If t equals 1, if type is 1, then we will get left and right numbers, c in left, c in right. After taking them, int change, there is going to be some change in our answer, and that change is going to be x first of all x0 index l minus 1, because l is inclusive. No, 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 no. Hmm. Because a L, huh? L minus 1. Uh, if we go to X, L minus 1, plus 1, we have to go R plus 1. Ah, now I get it. L and R are one indexed. L minus minus, R minus minus, or instead of that, we can do L minus 1 minus 1. Take XOR of that thing with R minus 2. R plus 1 R. Okay, that is correct, and that is what I wrote the last time, but my reasoning for the last time was messed up. Now it is correct, even though it is the same thing at the end. X1 R. And apply that change to ones, XOR change, and zeros, XOR oh, zeros, XOR change. Else, if we are on the operation with type 2, we take in G, and if G, then 1. See out, return once, space or a new line depending on Q, if Q is 0, if not Q. Let's see out. Okay, that is bad. See out depending on G. If G is there, then other ones, otherwise ze zeros. Yeah, that is it. And then space or a new line depending if not Q. That should be correct. Hopefully, 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 hopefully. Let's see. And it hopefully is actually correct. Okay, it is running. It is still running on test 2. It is still running on test 5. Somehow. And hopefully I didn't mess up in the implementation. Okay, it is running. Okay, 9 and then 11. Okay. And then 14. 14 is a nice number. 2 into 7. Both are prime. 16 square of 4. 18. 18 feels like a special number. 3 square into 2. 2 square into 5. 20. Okay, shit, it is running. 2 into 20. 11. We will see that updated here. 13 into 2. Accepted. Cool. Shit, I didn't start this when I was answering the question, talking to the chat. I stopped the clock watch, the stopwatch. Shit. Let's say it took, I guess it was, yeah, when I stopped this thing, stopwatch, we already wrote the first thing. So let's say 30 minutes. Yep, 30 minutes is fine. And a refresh. And how long has it been? It's been 2 hours and 56 minutes. But it feels much longer than that. Shit. Okay, so what did we do in this question? Data structures, fan. Zor is a nice thing. Zor is a very nice thing. Zor is I guess Zor is the only operator, binary operator, which has memory. Zor is the only binary operator which has some memory. We did do this. That is cool. Rank has also gone up a bit. Let's go to tutorial. Or before going to the tutorial, let's guess what the tags are going to be. And the tags are going to be prefix, prefix, and yeah, prefix and number theory, maybe number theory, maths, prefix and maths, bit masking. Okay, you call this DP. This was not DP. This was not even that. Maybe shit. Maybe I did this in. Okay, maybe I did this using some other method than the one in their tutorial. This is question number E in division 3. Okay, this one was kind of intense. Selling, no, this one, tutorial. Okay, shit, that is big. Of course, this problem has solutions that use data structures. For example, you can use a segment tree. I don't know what a segment tree is. We will have to read up on the, let's see, segment tree with a range updated to solve it in this time, or you can use a square root decomposition to solve it in this time. Okay, in this singular line, I do not understand what segment trees are or what is square root decomposition method. However, of course, we do not expect participants in Div 3 to have knowledge of these advanced data structures, so there is a simpler solution. Okay, but what are segment trees? Where can we read about segment trees? CP handbook. Segment trees. Wait. Segment trees revisited. Okay, and we have segment trees here. Okay, we can read about segment trees there. And the second thing was square root decomposition. Shit, is it also here? No, it is not here. Is it in CP algorithms? CP as in competitive programming. There is search right here. Square root decomposition. It is not here. What is square root decomposition? Okay, it is here. SQRT. Okay, it has been shortened based on data structure square root decomposition. So we have two things that we will have to read about: segment trees and square root decomposition. However, they will not be used here. We will store two variables x0 and xi, which represent XOR of all groups 0 and 1s respectively. When answering a query of type 2, we will simply output either as x0 or x1. Now we need to understand how to update x0 and x1 after receiving a query of type 1. Let's first solve a simplified version. Suppose that in type 1 queries, only single character of the string s is inverted. That is L equals R. In all queries, type 1 queries, let's see how x0 and x1 change after this query. If that was 0 and became 1, then the number AI will be removed from 0 group. So we need to invert XOR of AI. How do we do that? We take XOR of x0 with AI. XOR is its own inverse operation. We can do this with, take XOR with AI, and in x1 we need to add AI, so we take XOR with AI. The same thing happens if Si was 1. If Si was 1, yes, this is the key observation when we invert. Yes, this is the key observation when we invert these changes in the same way, regardless of whether the inversion was from 0 to 1. Therefore, to update x0 and x1 after a query of type 1, with parameters L and R, we need to do this. Take this XOR. To quickly find XORs on a subsegment of this, we can use prefix of XOR. Yes, this is the exact thing that we did, but we do not know what are I do not know what are segment trees and what is square root decomposition method. And I would say it's been 3 hours and 3 minutes, and in that time we have solved 3 questions successfully. We got messed up with this question because this question requires some GCC specific library, which I will add later off stream to my Clang compilation method. And yeah, this is pretty cool. We did 3 questions at 1500 rating. That is good. In the first one, we took 19 minutes. The second one, we took 16 minutes. And for the third one, 30 minutes. That is fine. Okay, and for today, that would be the end of today's stream. And thank you for being here. Bye.